We will now take questions now.
For those of us who don't follow this on a daily basis, I wonder if someone would give a 2-minute history of PFAS. I mean, we know it's firefighting foam, it's nonstick cookware, but it's appeared in the last 10 years as a contaminant, and it must have been used much longer. Why did it take so long to figure out how to answer it?
I'll start and start and get so it's been used
as firefighting foam, and that was definitely a reason why it's so widespread, because every time they tested equipment, every time they washed out a truck, every time they practiced putting fires out, it was sprayed. And before, for a long time, fire training facilities didn't even have concrete pads. It did this and it did it on grass. So it really got everywhere. But it's also used in surface treatments. It's used in carpets. It's used in cleaning products. It's used in chrome plating. It's used in manufacturing. It's used in greases, oils, electronics, semiconductor manufacturing. It's really used in an astounding number of industries. And for a long time, because it was seen as innocuous, it had no emissions controls whatsoever. So you can hear anecdotes of folks who worked at DuPont 3M that would take extra home to use as soap for their dishes because that's how innocuous they were. So I think it's just lack of controls and pervasive use.
Just add one little thing to that, which is that we're only really as good as our analytical chemistry to some extent. We didn't know it was there for a long time. I think they first found PFAS in human blood in the 70s. There were some inklings of it. But as our instrumentation gets better, we can find more and more trace level emerging contaminants in the environment. So we're kind of slowly seeing more because our technology is advancing. That's kind of one of the reasons we weren't aware, even though we were using it.
And maybe I'll add one more thing about that, because Carrie was also specifically talking about the bioaccumulation of these compounds. All of our history of bioaccumulative persistent organic compounds is with lipophilic, neutral organic molecules like PCBs, like DDTs that build up in fats. And if you went out and sampled, fats and lipid tissues, you would not find PFAS for the most part, right? Because they're different. Nobody expects something that's anionic at environmentally relevant pH to be bioaccumulative. So it's a little bit of a curveball.
Hi, mine is just a quick comment for Dr. Scott. So one of your slides had a bullet that I think was left over from a couple of years ago that I would think needs to be removed. It said something like, and I'm paraphrasing, that just because you think you want it doesn't stand it for the PFAS doesn't mean it's not safe. And I think in light of what we've seen over the last week, we have, as you know, PFAS is 10, PFOA is 10. We have all these other ones that the state's now looking at. They go to the recommend of 10, we 6 PPT. And I'm not sure that the Science Department still wants to say that that's perfectly safe, right? So I just want to request that you look at that, look at it again, maybe think about the wording. Just seemed a little, in light of everything we've heard today, that maybe that's not the best word to use.
So I don't think you're looking for a response to that. I'll just note that as a comment.
Yes, that's all, yes.
Yeah,
Unless you'd like to respond.
I'd love to, but the department probably, I have to put up the release that our EPA colleagues had at the end. This is my assessment of my opinion. It doesn't necessarily reflect anything to the health department, but duly noted, thank you.
I have another one for you. So you mentioned they gave you
This
heartburn.
is a non-order
There's
question.
a question. So you mentioned that it gave you heartburn, the new health advisories. That seems like an understatement because I don't even know what you do in this situation. Like, is this a constant public notification that you're going to be above that level? And analytically, you can't even get to that level. So just in a general sense, like what do you all do in this situation?
So I guess I'll start. What I meant by partners, because I think you're nailing on that. I think Adrian's comment really kind of hits on it too. It's wording is important, messaging is important, you know, and so we're on a path and we think that the path looks like this, and then we're given additional information and we have to adjust what that messaging would be. So, you know, what we do is we assess the new guidance and information and see where we are and what's appropriate now that the information is evolved. We're continuing to try to evolve on that. It's very difficult, right? Because when I started with this, I think what was the health advisory was 400 at some point, and then we've gone from there to 70. I thought that okay, and then now we're at 0.004. So you can imagine, as a regulatory body, you're trying to develop your steps forward, working with what you think is the science and it is challenging, but it's part of the challenge.
I just want to comment on the analytical challenges with these new health advisory levels. And analytical measurement of PFAS has always been a challenge. It's not because you cannot detect, it's because of background contamination. Because these chemicals are everywhere, and even a small smudge can show a peak in your instrumentation, and you cannot use the data. Unfortunately, you need to throw out, even if you see a background contamination. And with such low levels, it's really going to be challenging for the analytical labs to have good QA/QC and confident data at that flow levels. That would be the first step. Focusing on improving the analytical robustness for detecting these people.
First question as well. I mean, I think that goes to the first question as well, because I mean, we have existing EPA methods that will return a number of compounds that seem to be like VOC, SOC. So it's not like we were accidentally seeing these things where we might have accidentally seen other compounds that could fit in those classes. These are specific analytical methods that were developed to look specifically for these compounds. I think, okay, one more question, Dan, go ahead. And then the last word.
I was going to ask, like, in light of this super low guideline, what does it make you think about the food supply as a source of PFAS? Because it's going to be, it's going to also be excess. So your colleagues who handle food have to rethink their PFAS approach.
Yeah. Well, I mean, the question is kind of, it's outside of my realm, but all I can say is that in being around toxicologists for long enough, as they've been grappling with the studies and trying to develop, there is any EPA certificates that are not admitted but identified as health advisories. That these numbers are based on an assumed exposure to drinking water, but not an assumption that you're not being exposed elsewhere. So it's kind of like those other exposure routes are being captured and assessed at an advisory level. But yeah, I was in a meeting the other day, and some gentleman I think we saw information about PFAS in rainwater. So your health advisory level is at 0.04. What's the concentration of rainwater? So what do you do with that? Okay, I think with that, we're going to move on to our last session of the day. So let's thank our panelists.